Okay, so here we're going to do two more examples of collisions that have conservation of momentum in two dimensions. But unlike my last video, these aren't going to involve right angles, which means it's going to be more complicated in terms of resolving x and y components. What will still be true is the law of conservation of momentum, which says that the total momentum in the x direction before will be equal to the total momentum in the x direction afterwards. As well, the same is true for the y directions. All the y's before equal all the y's after. So we're actually going to be able to solve this question here that you see by only using the x coordinates, and we aren't going to have to worry about the y coordinates. Anyhow, so here we go with this first example. You see a ball A that has a mass of 2 kilograms traveling east at 1.5 meters per second, hits a stationary ball of mass 1.5 kilograms. And that means that the velocity of B is 0 because it says stationary. Now, after they hit, you see here from the picture that ball A goes traveling off on a trajectory that is east 25 north. And you see that the VA afterwards, the VA prime, is 0.45 meters per second. Afterwards, for ball B, we know the direction it went. We know it's going 15 meters per second on a trajectory, 15 meters per second. We know it's going at 15 degrees south of east, so east 15 south, but we do not know the speed that ball B has after the collision. And that's what we're trying to figure out. So we're going to set about trying to solve that by doing a conservation of momentum question. So we know that our total momentum before in the x direction is going to be equal to the total x after. So looking here, my MA and VA, that I can get a momentum of object A. It is just the mass times the velocity. So it's 2 kilograms, and the velocity is 1.5 meters per second. So you're dealing with 3 kilogram meters per second, and that direction is due east. And that is all in the x direction. So that's actually PAX of 3 kilogram meter per second. The momentum of object B is 0 because the velocity is 0. So clearly 1.5 kilograms times 0 meters per second means that PB is 0, and that means that the x part is 0 before. So now looking at my picture, I'm going to return to that information down there, but I'm just going to, if I can get this to line up just right. We know that the mass of A up here is still 2 kilograms. So I can get the PA prime, the momentum of ball A afterwards, by doing MA VA prime. And so I would get 2 kilograms times 0.45 meters per second. My PA prime is going to be 0.90 kilograms meters per second. That is PA prime, the hypotenuse. 0.90 kilogram meter per second. I can use this hypotenuse and the angle of 25 to get PAX prime. I can get the x component of that hypotenuse. So the PAX prime is going to be PA prime times cos 25 degrees. So if I set up what cos 25 would be, just to show you where it's coming from, cos 25 is adjacent, so PAX prime over hypotenuse, which is PA prime. So rearranging that, PAX prime is just PA prime times the cos of 25 degrees. So 0.90 kilogram meter per second times cos 25 is going to give me my x component of A after the collision. And that comes out to 0.8157. kilogram meter per second. Now, because I don't know PB prime, if I don't know VB prime, then I don't know PB prime, and therefore I can't figure out the x component of that. So PB x prime is unknown at this point. But if I use my conservation that says that the total x before equals the total x after, then I know that this x before and that x before has to add up to give this x after and that x after. So I'm going to set that up as an equation. My ax before and my bx before has to be equal to ax after and bx after. So if I fill in numbers, 3 kilogram meter per second plus 0 kilogram meter per second is equal to 0.8157 kilogram meter per second plus the PBX prime. This is what we can solve for. We'll take the 0.8 to the other side. So 3 minus 0.8157 kilogram meter per second again is going to give me what my PBX prime is. So that, when you subtract them, comes to 2.184 or so kilogram meters per second. So we now know the x component right here, this thing. We now know the x component of the momentum. We know it's 2.184 kilogram meters per second. Since we know the angle, we can solve for the hypotenuse here. If you know one side of the triangle and the angle, we can get the hypotenuse. So if I label it on the other triangle, you now have an x component of 2.184. We know the angle was 15 degrees, and we want to know this hypotenuse, PB prime. So the cosine of 15 degrees is going to be equal to the adjacent side, 2.184 kilogram meters per second, divided by the hypotenuse, PB prime. Basically, the cos of this angle is equal to the adjacent over hypotenuse. So now, if I want to solve for PB prime, it goes up and the cos 15 goes down. And so you're left with PB prime is equal to 2.184 kilogram meter per second divided by the cosine of 15. And then you get a hypotenuse which is bigger, as it should be, and you get 2.26 kilogram meters per second. The question you might think you're done, but the question didn't ask for what is the momentum of B after. It asked for the velocity of B after. So you take the one last step, which is the momentum divided by the mass. The momentum of B after is this 2.26 kilogram meter per second, and the mass was 1.5 kilograms. And if you divide that, you basically get 1.51 meters per second. And we knew the direction was 15 degrees. So if you wanted to write the direction, even though it was already given, it was east 15 degrees south. But this was the trick, was finding out the speed of B afterwards. So definitely a step up in complexity from previous question that we covered. Speaking of a step up in complexity, take a look at our next question. The next question has an object, A and B, coming in, both of them before, on angles, hitting, and both of them careening off at angles afterwards. So if we would set up, you have 15 kilograms is the mass of A, and you know its initial speed is 5.5 meters per second. Object B is 8 kilograms. Its velocity is 6 meters per second. This one comes in at a 30-degree angle, strikes the other one coming in at 20-degree angle. Afterwards, I'm just going to assemble the information here. MA is still 15 kilograms. VA prime is written up here as 1.44 meters per second. MB is still 8 kilograms. And VB prime is unknown. So we're going to be doing something very similar to the last question. We're going to try and figure out the PAX here. We're going to figure out the PBX here, and because we know that the two of them added up have to equal the same thing as whatever the sum of PAX prime and PBX prime are. The two x's before have to be equal to the two x's after. I'm going to be able to calculate 3 of those because I know these numbers. So PAX I can get, and I'm going to do it in a second. PBX I can get, so I'll get that next. PAX prime will also be a calculation. I will then solve for PBX prime, then get the hypotenuse afterwards, and divide by mass. That's me illustrating how I'm going to go about solving the problem. So first I'm going to get PA. PA is MA times VA, so it's 15 times 5.5. So if we do 15 times 5.5, we get 82.5 kilogram meters per second. So we know the hypotenuse. Therefore, we can get the x component of that by multiplying the 82.5 kilogram meter per second times the cos of its 20 degrees. And when you multiply by cos, you get 77.5 kilogram meters per second. So we know PAX, it's 77.5. We're going to need that number for later. Now we're going to go get PBX. So to get PBX, I need PB first. It is MB times VB, so it is 8 kilograms and 6 meters per second. Well, that's 48, 6 eighths is 48 kilogram meter per second. That's what PB is. Now knowing what PB is isn't going to quite help me. I need to figure out what the PBX is. So to get the x component of PB, you're going to take, so to get PBX, you're going to take the 48 kilogram meters per second and you're going to multiply it by the cos of 30 degrees, which is the angle up here. So 48 times cos 30 gives 41.6 kilogram meter per second. So this is the x before for B. So those two x's are going to be used. I now need to go over and look at the after momenta. So the after momentum for object A, you'll get PA prime, which is MAVA prime. So 15 kilograms and 1.44 meters per second. My PA prime is going to be 21.6 kilogram meters per second. That doesn't help me because I need PAX prime. So to get the x component of that, I multiply the 21.6 kilogram meter per second times the cos of 25, and therefore my x prime comes out to 19.6 meters per second. So I now have 3 of the 4 numbers that I said at the beginning, because I said that PAX prime plus PBX prime is going to equal PAX, plus PBX is going to be equal to PAX prime plus PBX prime. So I'm going to set that up as a formula. PAX and PBX has to add to give the x after and the other x after. All the x's before must be equal to all the x afters. So my PAX prime is the 77.5. My PBX before is 41.6. My x after is 19.6. And my PBX prime, we don't know. But we can calculate it by taking this to the other side. So 77.5 plus 41.6 minus 19.6 gives the x prime of b. And when you subtract that, you get 99.5 kilogram meters per second. Okay, like the last question, knowing the PBX doesn't quite help. We're not done at least, we need to get the hypotenuse. So the cos of 45 is going to give the adjacent PBX prime over hypotenuse, which is PB prime. Like the last question, those two switch places. So PB prime is PBX prime divided by cos 45, which means the 99.5 kilogram meters per second must be divided by cos 45. And when we divide that by cos 45, we get ourselves 140.71 kilogram meter per second. Question didn't want to know the momentum. They want you to take the one last step and divide that by the mass. So to get VB prime, you take this PB prime that you just calculated, divide by mass of B. So the 140.7 kilogram meter per second, divide by mass of B, which is 8 kilograms, gives us the grand total of 17.6 meters per second, and we already know the angle because it was listed in the question of 45, so that is east 45 south as your direction. So definitely complicated set of questions. I've got 3 questions for you to attempt that model this very carefully, so you should be able to use these 2 as good examples to try and answer the following 3 questions. So good luck.